Okay, so this is a very straightforward question. Using the properties of determinants, I have to prove that this LHS determinant on simplification will give me ABC plus BC plus CA plus AB, right? So one idea is to just open this, but since the question clearly states that we have to use the properties of determinant, we will have to follow some steps in which we will use some transformations. Okay, so let us start with the LHS quantity. This is my LHS quantity, the determinant. To use the transformations effectively, I'm just doing this first step where I take A common from the first column, B common from the second column, and C common from the third column. So overall, I am taking A, B, C common from the determinant, and my individual columns will convert to 1 upon A plus 1, 1 upon A, 1 upon A. Second column will become 1 upon B, 1 upon B plus 1, 1 upon B, and third column similarly will become 1 upon C, 1 upon C, and 1 upon C plus 1, right? This is my new determinant. Okay, now I am just using very simple transformation where I will convert this determinant, column 1 of this determinant, as column 1 goes to column 1 plus column 2 plus column 3. Alright, so what will happen? Now my LHS quantity will become ABC, and now column 1 becomes 1 upon A plus 1 upon B plus 1 upon C plus 1. This is the first row of column 1, right? Okay, now second element of column 1 will become again 1 upon A plus 1 upon B plus 1 upon C plus 1, and similarly third will also become 1 upon A plus 1 upon B plus 1 upon C plus 1. So this is actually the benefit of taking A, B, C initially outside, so that we get similar values in the first column, right? And the other two columns will remain as it is, 1 upon B plus 1, and 1 upon B, and the third is similarly 1 upon C, and 1 upon C plus 1. So these are the values that we get. Now best idea would be to take this value common from the first column. So this will lead to a very simple determinant. First of all, what I take common is 1 upon A, 1 upon B, 1 upon C, and 1. So 1 upon A plus 1 upon B plus 1 upon C plus 1, and then there is this determinant which has 1, 1, 1 in the first column, and 1 upon B plus 1, and 1 upon B in second column, 1 upon C, and 1 upon C plus 1 in the third column, right? This is much better determinant to solve. Further, to simplify this, we can do one step. We can convert our row 2 and row 3 now. Okay, so my row 2 now goes to row 2 minus row 1, and row 3 goes to row 3 minus row 1. I am doing this transformation to make these values 0. Okay, so if we do this, what will happen? Let us see. So initially again I have what? I have ABC into 1 upon A plus 1 upon B plus 1 upon C plus 1, which is already outside. When I do the above mentioned transformation, my first column will remain as it is. My first column will remain first row will remain as it is, 1 upon B and 1 upon C. But my other two rows will give me values 0 and 0 here, which was actually the target, and also I will get 0 in the other two places also. Other than that, I will be left with 1 in these two places. This is much better expression to solve. Now just open this determinant, just solve this determinant about your column 1, right? Since two values of this column are equal to 0, now solving this determinant has become very easy, right? So outside value outside the determinant is ABC into 1 upon A plus 1 upon B plus 1 upon C plus 1, and then when you solve the determinant, what value will you get? You will get 1 into 1 minus 0, right, which is again equal to 1, which effectively gives me only the value equal to 1, right? So this now becomes my value of the determinant on simplification, correct? So if I further open this bracket, what will I get? I will get ABC plus AB plus BC plus CA, which was the expected result, hence proved.